So, our objective for today, I can solve systems of linear inequalities by graphing. Let's read together. 1, 2, 3. I can solve a system of linear inequalities by graphing. So we're moving on from systems of linear equations, and we're going into inequalities. And we're going to close this section on equations and inequalities, which are linear. And we're about to start on quadratics, which means we're coming back to polynomials, your favorite. Yeah, polynomials. So, with that said, what are systems of linear inequalities? You need a Freire model. Here he goes. Systems of linear inequalities are a set of two or more linear inequalities that have the same variable. A set of two or more linear inequalities that have the same variable. A set of two or more linear inequalities that have the same variable. A set of two or more linear inequalities that have the same variable. A set of two or more linear inequalities that have the same variable. A set of two or more linear inequalities that have the same variable. Once again, systems of linear inequalities, the set of two or more linear inequalities that have the same variable. The set of two or more linear inequalities that have the same variable. The set of two or more linear inequalities that have the same variable. The set of two or more linear inequalities that have the same variable. The set of two or more linear inequalities that have the same variable. Turn over the definition for system of linear inequalities, please. Be nice. Here we go. Examples. Copy this down. Y less than 3x plus 1, negative 4x plus 2y greater than 6, and negative y less than x minus 5, and y greater than or equal to 2x plus 1. Copy that, please. Here we go. So, by now, if you notice, the definition is very similar to what we did with systems of equations. Is that correct? It says two or more linear inequalities. Are they two or more? Yes. With inequality symbols? Yes. Same variables? Yes. Same here? Yes. So let me ask you a question. If I was to take these brackets off, will this be a system of linear inequalities? Why? Because it's two or more linear inequalities. They have the same variable, all of them, right? Okay. Tell your neighbor, as you copy these next ones, why these are not examples of systems of linear inequalities. Go. Very good. Copy that. Carissa, why is this a non-example? Their equation, so what is this called? That is correct. System of linear equations. Very good. So, why is this not an example? Okay, hold on. I'll wait. I'll wait. You guys ready? We will finish, just letting you know. Okay, go. What was it? Sorry, the last one. Right. So, just remember two or more linear inequalities, and they have to have the same variables. By now, guys, for the rest of the semester, I want you to start filling in information in here ahead of me. Don't wait for me to start putting up what you need to write in there. You should actually, by the definition and examples, non-examples, be able to abstract the critical attributes. Does that make sense? All right. So, steps. Copy this, please. Step 1, solve for y. Step 2, graph the inequalities. Step 3, check a point and say the solution set. Step 4, state the domain and range for solution set. Copy that? So, these 4 steps, guys, this is for graphing, okay? It says solve for y, graph the inequalities, check the point and shade the solution set, and state the domain and range of the solution set. So for right now, before we get into graphing, I want to make sure that we understand what we're looking at in regards to solutions to systems, okay? So when we got to systems of equations, you were given something like this where it says, tell whether the ordered pair is a solution to the given system. You guys remember that? Okay, and then they give you a point and they give you a system. So copy this one, example 1A. We're going to do a couple of these just to refresh in our memory to make sure we understand what we're talking about in regards to being a solution to the system. Okay. Copy that. So then they give us the point -1, -3, and the system is y less than or equal to -3x plus 1, and y less than 2x plus 2. Okay? So, before we continue to graphing, let's think back. If this was a system of linear equations, what do we need to do with this point to ensure that it's a solution to that system? Think about it first. Okay, talk it over with your neighbor. What do we need to do if this was a system of equations with that point? Okay. All right, guys. Everyone, what do we do? Substitute the values, right? So let's write this first inequality, y less than or equal to -3x plus 1. On this side, I'm going to write y less than 2x plus 2. And we're going to substitute the values x, which is -1, and y, which is -3, into each of those. So this is -3, and for x is -1. So this becomes less than or equal to -3 times -1 plus 1. -3 is less than or equal to -3 times -1, that's 3 plus 1. Is -3 less than or equal to 4? Yes, that's true. All right, so that means it has to be true also for this one. Let's find out. -1 and -3, bring everything else down. This becomes -3 less than -2 plus 2. Is -3 less than 0? Yes, it's true. So once again, to refresh in our memory, in order for it to be a solution to the system, it has to be true for what? For both. That is true. So make sure you remember that so that when we get into the graphing part, it makes sense what we're going to be looking at. Okay? Let's do one more of these just to make sure you got this. Okay? Here we go. Example 1B. You don't have to copy the instructions, just copy the point and the system. -1, 5, and the system is y less than -2x minus 1, and y greater than or equal to x plus 3. Copy that and go. Okay, question. Who did this? I'm sorry. Who did y less than -2x minus 1 and y greater than or equal to x plus 3? So far, so good? And then you substitute in this one, and you found out that it was false. Is that true? So it didn't work for this one. Okay? Who went and substituted into this one? Okay? Now let me ask you again. What was the purpose of the previous example of me saying that it needs to be true for both. Substitute into both to make sure it's true for both, right? Therefore, let's see, think outside the box. If it wasn't true for this one, what can you concur without even that it's not a solution to the system? Therefore, did you need to substitute in this one? No, you just spent like 2 minutes of your life doing something you shouldn't have, or you shouldn't have had to do. Does that make sense? So try to think a little bit more outside the box when you're approaching some of these problems, so you can save yourself some time and move on to the following thing, whatever it is that we're doing. Everybody understand? So that's why be on point with your definitions, so you can be ready for what's coming next. All right, set your notes on the side. Get your graph paper in front of you, the big graph paper. Okay. On the big coordinate plane at the top left, copy this down. It says, example 2A. On the big one, yes, top left, copy where it says, graph the system of linear inequalities. Give two ordered pairs that are solutions and two that are not solutions. The system given is negative 3x plus 2y greater than or equal to 2, and y less than 4x plus 3. Copy that, please. Here we go. Can you read us step 1, please, Santi? What's step 1? Okay. What do you guys notice? It's already solved? Let's see. Oh, the bottom one. So the only one we need to change is this one. So let's rewrite it down here. Negative 3x plus 2y greater than or equal to 2. And let's solve for y. Line down the equal sign. All right, so what do I do? Add 3x. Add 3x. We're left with 2y greater than or equal to 3x plus 2. What else? Divide by 2 on both sides. Y is greater than or equal to, remember for slope we don't need decimals, we need fractions, right? So what do we have? My goodness. 3 over 2x plus 1. Okay. Just remember, whenever we're talking about graphing, make sure you leave your slope in fraction form. Okay? So, with that said, look up, please. Let's start with this equation. This inequality. Look up, the one that was already solved for. We're not going to use this one anymore. Let's look at this one. We start where to graph? Positive 3. Okay? So positive 3 is right there. What is my slope? 4 over 1. That means 4 steps up, 1 to the right. So from here we go. 1, 2, 3, 4. 1 to the right. Plot your point. Do it again. 1, 2, 3, 4. 1 to the right. Plot your point. Do it again. 1, 2, 3, 4. 1 to the right. Plot your point. Do it again. And then before you sketch your line, don't sketch your line yet. Wait for me, and then I'll explain the next piece before we actually sketch our line. I just want to make sure you understand the concept of what we're talking about here. Okay, pens down, eyes up here. Here we go. Look up, please. So, with regular one variable inequalities, we were given a number line like so, right? Yes. You guys ready? Yes. Okay. And if you were given an inequality symbol that looked like this or like this, we knew that the point was going to be what? Open. Everybody understand that, right? However, that was in one variable. Now that we're in two variables, now we're looking at y and x. So now, in order for us to understand that, we're going to do a couple more things. But before that, does everyone understand that this inequality symbol is an open point? Yes? Does everyone understand that? All right. So good. So now, check this out. Look at this. This could be an actual line. Look at the inequality symbol. This would be an open point, right? But this is an actual line. So let me show you what that line looks like when it has this symbol. Talk it over with your neighbor. Why is it that I made my line like that? Talk it over, please. Elaborate. Okay. Jonathan, let's see, elaborate for us. Over here in the example that I gave with one variable, we said that it's an open point because it's only one point and it doesn't have an equal sign on the inequality symbols. But this is a line. What did you discuss in regards to why did I make that a dashed line? Okay, the question was, why did I make this line dashed instead of making it a solid line? Okay, because it doesn't have the equal to. Who said something different? Who can elaborate other? Sergio? Did everybody picture that one? So since it's an open, look up please, this inequality does not have an equal sign underneath. So Sergio said, imagine a lot of open points going this way. All of a sudden you start seeing a lot of dotted lines like this, right? But if it was a solid point, it would be a solid line all the way across, right? Because the line is made up of a bunch of points. Very good. So get your ruler and make your line, but you're going to make your line with dash. Go dash, 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 all the way through. Arrows at the end. And once again, if you have your colored pens, make sure you're using them. Okay, here we go. So we got our line dashed, but we're still not done. Pay attention, please. So I'm going to go ahead and get this out of the way. Well, all right. Look up, please. So the second part that I need in order to graph, since now we're in the two dimension, we're no longer in one dimension or one variable. Now we have two. What I need from this inequality is this. I need the y, the inequality symbol, and the constant. The constant is positive 3. If I was to graph this, look up, please. Look up to the screen. If I was to graph this here, we know what to do, right? But now, since it's in a two dimension, now this y-axis is like this. Is that correct? Do you guys see it over here? do you know how to graph this here? Yeah, right? Let's see. Here it goes. We start at what? At 3. There it is. It says y is less than 3. What numbers are less than 3? 2, 1, and everything in the negative going this direction, right? Does that make sense? However, since now we're in the 2 dimension, we're going to do this. So everything under and to the right of the line that we just drew. Everybody with me? So shade your graph, everything under this line that we just drew and everything to the right of that. What's that? Right. All right, now that we got that one done, let's go to the second one. I'm going to switch to blue. Where do we start on this second one?
1.
At positive 1, so we plot our point. What is our slope? 3 up, 2 to the right. So 1, 2, 3, 2 to the right, plot your point, do it again. 1, 2, 3, 2 to the right, plot your point, do it again. 1, 2, 3, 2 to the right, plot your point, do it again. 1, 2, 3, 2 to the right, plot your point, do it again. Now let's circle our inequality symbol. What kind of line will this be? Tell your neighbor. That is correct. It would be a solid line because it has an equal sign on it. So therefore your line should look something like that. Okay, so now we need to shade. So what information do I need from this inequality? The y greater than or equal to, and the constant. What is my constant? Positive 1. So let's see, where's y1? Right here. What number says y is greater than 1? What numbers are greater than 1? 2, 3, and everything going this way. Therefore, our shading should be above the blue line. And everything to the left of the blue line. Now, for those of you that are using pencil, that you don't have colors, a way that you can distinguish one from the other, if you did the red one down, then the blue one, do it to the left, across like that, so you know it's a different type of shading. Okay. All right. Now, okay, here goes the last part. Look up, please. Look up. Now that we have both shadings, according to what we did earlier, look up, watch what we did earlier. We said that in order for a point to be part of the solution of the system, it has to be true for both, right? Look at this graph. Don't say anything. Do you see the solution to the system? If you don't see it, here it goes. Where both shadings intersect, that is what we call the, let's label it, solution set. Solution set. So why is that the solution set? Because both shadings intersect. That means any point that it falls in there is going to be true for which one? Only one? No, for both. So with that said, it said, give two order pairs that are solutions. So who can give me one order pair that is a solution? Go ahead, Dylan. 11. Oh, 4, 11. Is that inside the solution set? Yes. Plot your point. Plot your point and write your coordinate. 4, 11, and write solution. I need one more. Alessandra? What is it? 9, 11. Look up, please. Is 9, 11 part of the solution set? No. Put an X on that one. Okay. Whoa. Yes, Francisco. I mean, Seabass. Go. What's another? 3, 8. That is correct. Label that one. 3, 8 is also solution. So, now that we have two that are solutions, who can give me one that is not a solution? Gianna? 1, -1. Label that one. Plot it. 1, -1. Who can give me another point that is not a solution for either one? Either one. Erica? -3, -6. Who notices that it doesn't hit any shading on that one? So this one, -3, -6 is not a solution. So in order to know that these are not solutions, I want you to put a big X on those 2 points so that we know those are not solutions. Okay? So, did everybody understand now what we did? Look at this one. Look up. -1, -1 would be a solution for which of these equations? For A or for B? For B is that one. One -1 is a solution for which inequality? A or B? A. How about -3, -6? Which one will that be a solution for? Neither, because it doesn't fall into any of the shading. So, home plate for tonight is on pages 316 and 317 only. Have a good one, guys. Enjoy your home play. See you guys tomorrow.